Hello guys, good evening. I am Prakash Verma, I am from Bosch. I like to call myself more product guy because throughout my journey I have been involved into the products in various forms. But before I continue with my talk, I would like to congratulate the organizers of this event because I saw the structure of the whole event was very well, the kind of talks that were arranged. It was kind of very informative, especially considering the students in mind. And I especially liked the last session. I think when somebody from the team comes onto the stage and talks about it, that creates, as per me, the biggest impact rather than the industry guys or anybody outside talking about it. So that definitely is commendable. With that, I will start my talk. Now, if you look at, can you just, first like, yeah. So now, if I close my eyes for a moment, or let's say if we close eyes for a moment, you can still think, you can still reason, but there is one vital thing that you miss. That is the awareness that is created because of the eyes, right? That's what is one thing that is there. Now imagine our robots are actually living exactly in that same state. They are able to do, let's say, high complex computing tasks that they are able to do. They are able to navigate in a very complex environment. Okay? They are also able to pick and place a complex component very accurately. But what they are not aware is the context. And that's where they differ with respect to the humans. Now, my talk overall today is about how multimodality is impacting the robotics. Earlier, Srihari spoke about the multimodality. I think the previous session where Ashish spoke about the edge AI, these are all kind of related topics, but I'm going to do a little bit focused discussion on the robotics part of it. Now here, before I continue, the next leap in the robotics isn't about faster computing anymore. Here it is about how a deeper perception could be created. That's where the context and other things becomes extremely relevant. Next slide, please. Yeah. Let's first understand what are the current challenges in the robotic perception. So if you look at, I mean, there will be many challenges. I'm talking about the top 3 challenges. First of all, if you look at, there is a largely sensory limitations. Typically, if you look at a traditional robo I'm talking about, it may either operate on the vision, that is, it may have a camera, or it may have, let's say, a proximity sensor, depending on the job that it is or the task it is supposed to accomplish. Okay? While it may be doing that thing very well, but with the single modality, there are a lot of challenges. Let's take the example of a camera. Now, camera you have trained, it will do, vision-based solution will do very well, but then there is a transparency, right? If you have to see through a glass or any other transparent object, you may have a challenge. If we are talking about, let's say, reflectivity, some light is there, because of that reflection, again, it will create a problem. So what it is supposed to look at, there may be some challenges on that. So that is one sort of challenge that comes from the limited sensory range. That's what I mean. Now, second is the contextual blindness. What do I mean by that? Now, let's say if I show a hand to a robo can easily detect that, it can label that this is a hand. But what it will miss is it will not be able to decipher whether the hand is for the obstruction or it is for the collaboration. And that's where the difference starts to come. So that's what we mean by the contextual blindness. Now the third element, if you look at, when we talk about fragile generalization. Now what is this fragile generalization? Now, I think in the previous talks you heard that if there is a model, you need data, you have to train that model with that data. Now, while you are training for that particular with that data, it may work very well for that data set. Problem starts to happen when the same model is deployed in the real world. Now, what is the difference? That's a controlled environment, limited data set. The moment it gets into the real world, now the problem starts. The model may no longer work for the unknown scenarios, and it is made for a specific thing. The moment you change that whole scenario, probably it may either not work or work in a limited manner, and that's what creates a boundary between a safe environment and adaptable environment. It is unable to do beyond a certain thing, so what you do, you create some guardrails. It has to operate exactly within that, and it cannot operate alongside with the human. So that's what is this. Go back. Yeah. So what I want is, when you talk about the modern robots, no, all these robots, they come with a, I mean, they are accurate actually, but they lack awareness. That's the first problem that they see. Now they are effective in isolation. That means when you give a limited environment, they are very, very effective. But the moment you change the context, there is a problem. Now if you look at, now let us look at what really is the current state. Let's, to understand better with respect to robo and the real person, what is the sensory gap? Now as a human, when I look at an object, okay, I will see the object, I will sense it, and I will probably touch it, right? Multiple senses starts working together. How my mind will operate onto this? My mind will work on all these things together. It will fuse this information and it will create a meaningful model, mental model for it. That's how I will look at the whole thing. Now, when it comes to robo, let's say especially we are talking about single modality sensors or robos. Now let's say if it is there is a vision-based solution or vision-based robo. As I explained earlier, it will start to fail in certain conditions, wherever especially you need more data points. Now just to give you one example, if you have seen a robo cleaner at home, now robo cleaner typically used to come only with one sensor that is based on LiDAR. Now LiDAR is there. If you see, it will go near the curtain. Now curtain is something that can be easily pushed, right? We as humans understand the curtain can be pushed, but for a robo vacuum cleaner, it will not be able to differentiate. It will not be able to differentiate between a curtain and a, let's say, a wooden object. Now only solution today that people are doing is they are using a bumper sensor. That means you really hit it hard and then you try to detect. That's what is there. Imagine if I am bringing two complementary senses. In this particular case, let's say I have along with the camera, if I introduce another sense which is able to give me, let's say, a texture part of it. For example, LiDAR. If I am able to fuse these two information together, and then I am able to make out what really this object is all about. Should I go around the object or should I really get into the object? So that's what is the difference between, let's say, human and a robo. And the moment you bring multiple senses together, that's where the magic starts to happen, because you are able to understand the context a lot better. Back. Okay, forward. Yeah. So while we are talking about, I'm missing one slide actually. So while we are talking about all the sensory gaps and other things, the biggest question that is in front of us is why we are discussing all this now. What has changed? Because, I mean, whatever I spoke, as humans, we understand this day in, day out. Now, the biggest thing that has happened now is there are multiple technologies that are evolving together and they are all converging at this point of time. And that is where now it is possible. I think in the morning when the talk was being given, it was told that, okay, neural network has been there for quite some time, right? So what has changed now? Why we are discussing all these topics now? And that's where if you look at, there is a miniaturization, there is a integration. Now what do I mean by that? Let's say if you talk about the compute. Now, in case of compute, what's happening is sensors are becoming much more simpler, they are becoming lightweight, and they are becoming much more smarter. Now what happens? If I have a very complex and a bulky sensor, you can do lot of solutioning, backing, putting it onto the cloud and other things. But what we need is not that we have to go to the PC. Ideally, the compute should come to me. That's where it becomes really a human part. Otherwise, they operate in a two different environment. That's where miniaturization and integration plays a very important role. Edge AI, I think there was enough discussion on Edge AI. Embedded intelligence is also almost similar. They are complementing each other. I will talk bit of connectivity. Now what happens? Again, this was also a topic that was touch based earlier. Now when I'm having lots and lots of data, now if connectivity is not strong, which means I have to operate everything in that particular device only. The moment my connectivity is enabled, which means I should be able to take all this information back onto the central compute if I want. Ideally, it is not that it's either edge or a cloud, it's normally a combination of this thing. Other thing that is making a huge difference is the digital twins. Now, what digital twins in this context I mean? See, when we talk about development, especially when we talk about the complex open world problems, solutions for the open world problem, you never know what is the real life scenario. So you want to do as much testing as possible. Let's say there was a earlier discussion about autonomous cars. Now, there is a long tail problem to it. How many scenarios you are able to test for? It is practically impossible to test for every possible scenario because you will never be able to release the product. Now, how do we go about solving this thing? That's where instead of doing a testing on a physical thing, you are moving from there. Can it be a testing on the virtual environment? That's where digital twin starts to play a major role onto it. So together, what I want to say is the compute technology, AI, and connectivity. Since they're all maturing together, that's where the multimodal perception is becoming a reality today. What the embodied AI stack looks like. I mean, again, it's a closed loop thing. Everything, any loop, if you look at it, finally we are talking about a sense, we are talking about understand, act, and learn. And this loop continues as humans, right? That's what we have been doing. And the power lies actually between sense and act, because that's where when you start to learn, that's where you apply, and next time we don't do that same mistakes. The moment this starts to happen with the robots, then the situation becomes much more improved. I will just give an example of, let's say, two different sensors, wherein, can you just go on? No, previous. Okay, continue. Yeah. So let's see. What I have done is here I have put two different sensors together just to explain you how they are complementing each other, or in what ways, what is their strength of individual things. Let's talk about the vision, which gives us the spatial understanding. That means understanding about the space in which we are operating. Now, with the help of vision transformers and 3D mapping, of course, you have to do it together with LiDAR. Once you do that, you create a semantic map of a particular scenario. You can do that, right? Once you do that, that's where you are able to estimate the depth, and you are able to create a meaning out of it. That's what you are able to do. But nevertheless, there is a gap. The gap is, as I explained earlier, the gap is, if at all there is a transparent object, there is a problem. Maybe reflectivity could also be a problem. And the third thing is, you cannot interact, because vision alone cannot help you to interact, because you don't know what it is for the feeling part of it. So that's where you can't interact with it just by looking at the things. Whereas now if you look at the touch, which is the other dimension, it is also one of the oldest human senses, right? We touch, we are able to feel. Now this part is possible through, let's say, tactile sensors. Today you can do that. Okay, you can also do a soft haptic solutions. Through that, you are able to actually get a feel of the object. Now, with that, you will be able to predict the force. You will be able to predict what could be the slip, considering you have understood a little bit of the texture, how smooth or rough it is, right? So when you are able to do that, what you will naturally do, you will be able to grasp, let's say adjust your grasp onto that, right? That's where you will be able to do it very easily. But again, here, touch alone, you will miss the awareness, which is created by the eyes part of it. So that's the kind of difference. So now, on one hand, vision provides you awareness, but it lacks experience. And touch, that gives you, let's say, ability to adapt based on what you feel, but it lacks the awareness. So that's the kind of different senses, but when they complement each other, that's where magic starts to happen. Now, how the multimodal perception looks like and how they build the overall understanding. Now here, the most important is, if you look at, it has to operate like a human mind, which means depending on my context, I will use the respective knowledge and I will not use either or. What I am looking at is, I have to fuse this two information and then I have to make some sense out of it. That's where the multimodal part comes into picture. So it is not about really adding the different senses, it is about creating a meaning. How much time I have? Already up, is it? Okay, yeah. So just so far I spoke about the, let's say, the things which is inside a particular robo. Now, if you switch gears and if you look at it, I'm talking about collaborative sensing. That means if we talk about multiple robos, how they can communicate with each other so that we are able to get a larger context. I think in the morning there was an example of the transport wherein we were talking about how do we create a right traffic scenario, or let's say understand the traffic and manage. That I call it as a heterogeneous collaborative sensing, which means you are not creating a fresh solution, you are using existing infrastructure, taking that into account and then creating a scene out of it. So that's what is the collaborative sensing. And all these are various opportunities that exist in front of us. I will play a video. Whatever I spoke so far, I will just play a video. This video is of a Bosch plant where you will see an active shuttle. Basically, that is for the intralogistics solution. That will help you to understand the context in which we are, whatever I spoke. Volume, please. Yeah. So while the video is getting played, this is a video of an active shuttle. It's an intralogistics problem in the plant. That means there is a milk run that happens. So you have to take the items from one place to other. It's a highly mechanical process. So instead of doing that, there are solutions which are there. So Bosch uses it within the plants, and also the same solution they are trying to deploy elsewhere as well. So that's where what you see here, right? So that line what you see is not, it is not following that line, it is just there.
I now call upon Kishore Dasri Garu to give away the special token of appreciation for the speaker. Thank you for that revolutionizing drive into the senses revolution, Mr. Prakash Verma. And I'm sure this brought us some sense into our senses. Made sense? Thank you.